Today we are going to do another question, which is check the check the correctness check the correctness of the relation h equals to 2t cos theta by rho r g, where t is surface tension and r is radius, rho is density, and g is acceleration due to gravity. So this is the question that we are going to solve dimensionally. So first of all, let's change the color because I accidentally put the wrong color. This is our blue. So now let's solve the question. So also h here is height. So h is height, t is the surface tension, r is the radius, rho is the density, g is the acceleration due to gravity. Cos theta is a trigonometric function, 2 is a number. So now let's solve it. So first of all, let's find the dimension of all terms involved in this. So the dimension of h, which is height, is L, because height is a length. After that, the dimension of surface tension is the most common formula of surface tension that you will find is force upon length. So it will be mt minus 2. So force upon length means this. And after that, we have density, rho. Rho is mass upon volume, which will be ml minus 3. Then we have of g, which is acceleration due to gravity, which is as same as of acceleration. And then we have of radius, which is a length, so it will have the same dimension as a length. And here cos theta and 2 are dimensionless, since trigonometric functions and numbers don't have dimension. So now let's check the dimension of the LHS and LHS and RHS, so left hand side and right hand side, to see if the relation is correct or not. So let's do it. So now the dimension of LHS is same as the dimension of h, which is just length. So now the dimension of RHS, right hand side, is the same as the dimension of 2t cos theta by rho rg. So let's add a bracket. They are supposed to be square brackets, don't mind the round brackets. So now let's continue. So the 2 does not have a dimension, cos theta does not have a dimension, t has a dimension of mt minus 2 divided by rho rg. So the dimension of rho is actually ml minus 3. The dimension of r will be L. The dimension of g is meter per second square, so it will be lt minus 2, since acceleration is length over time squared, or velocity over time. So now let's check out the dimension. So let's see mass. The mass cancels out, so it will be m to the power 0, which I'm not gonna write since you don't need to write powers raised to 0. Now then, let's see length. There is minus cubed L, which will give us just L squared. And there is also L over here, which will actually give us let's go back, which will actually only give us L, which will only give us L. So L cube, L minus 3 plus 1 plus 1, which will give us minus 1, which goes up and becomes L. Let's see t minus 2, which cancels out, so you get L. So as you see, the dimension of LHS and the RHS match. So we can conclude it like, since dimension of LHS equals dimension of RHS, the relation is dimensionally correct. It may not be physically correct, but it is dimensionally correct. But in this case, it is also physically correct. So in the next video, we are going to do another question. Till then, bye.